In this video, we will discuss about scalability. First, we need to understand what is meant by the scalability. What is meant by scalability? For example, if your application is scalable, that means what? What is meant by the scalability? First of all, if you have an application that needs to be deployed into the production, one of the most important criteria to deploy the application into the production is scalability. It is the most important criteria. Okay, the scalability means if your application behavior does not change, even there is an increase in users, increase in data, increase in requests. That means your application up and running, even the number of users was increased on day by day, even data volume. That means whatever the users trying to ingest the data into your application, even your application should be up and running. At the same time, if the request was increased to your application, it should be up and running. It is not only applicable for an application, it is also applicable for the databases. It is also applicable for the infrastructure as well. Okay, then only we are capable to deploy the application into the production. Okay, to make your application scalable, we have lot of factors involved in it. Let us discuss these factors in detail. Okay, factors affecting the scalability. Sorry. Factors affecting the scalability. The first factor is stateless applications. Stateless applications. Okay, your application is must and should be the stateless. Before understanding the stateless applications, we need to understand the types of an applications with respect to the state. With respect to the state, we have the two type of applications. One is the respective to the state. There is two types of applications. One is stateful applications. Second one is stateless applications. One is stateful applications and second one is a stateless applications. We need to understand what is meant by the stateful applications, what is meant by the stateless applications. The stateful applications means applications maintain information between the requests. These applications are called the stateful applications. That means, for example, let's take an example so that you can understand the better way. If you had an application, if you take this an application, it had the request one. It has the request two. Okay. If your two requests is maintain the common information between them. Common info. Okay. Those applications are called the stateful applications. Example, session data. Okay. For example, if the application has a two requests is belongs to the user. If the first request will comes, the user data will be stored in the sessions and the second request can easily access that session data. Okay. That means there is a dependency between the dependency between the requests between the information. Okay. We had an information dependency between the two requests. Those applications is called the stateful applications. Then what is meant by the stateless applications? The stateless applications are the applications the request is independent of an everything. Okay, request is independent of an everything. The request will contains a complete information so that it does not depends upon the another request. Simple example for the another example for the stateful is some information it is trying to store in the server memory. Server memory. Okay. Later, what is meant by the server we will discuss in the later in this video so that you can easily understand. This kind of applications are called the stateful applications, where the stateless applications are where the request had the complete informations. Stateless applications does not have common information between the requests. At the same time, they does not store anything in the server memory. Okay, so this is the difference between the stateful applications and the stateless applications. But if your application should be a scalable, that means your application should be the stateless applications, not the stateful applications. Why the application should be the stateless application? To get the scalability. Okay, we will discuss after the section of an horizontal scaling and the vertical scaling. We will discuss the later. We will discuss why the application should be the stateless. You have a clear-cut idea. Okay. For now, you remember that what is a stateful application and also the stateless applications. Next factor is horizontal scalable. Horizontal scalability. To understand the horizontal scalability, you need to understand the types of scalabilities. Okay, types of scalabilities. There are three types of scalabilities. First one is horizontal scalability. Second one is vertical scalability. Sorry, not the scalability, scaling. It is an horizontal scaling. Scaling techniques. Horizontal scaling, vertical scaling. Third one is dynamic scaling. Okay. Before understand these three types, we need to understand what is meant by the server or node. If you deploy any kind of an application which you write the code, it should be deployed in the server in the production, whether it will be the cloud or whether it will be the on-prem. Okay, so that for the first we need to understand the what is meant by the server clearly. Server. Server consists of three components. First one is CPU. Second one is memory. That means RAM. Third one is disk. Okay. Applications, the generally all our applications utilize these two things, CPU and the memory, but the databases will utilize the third thing. This one is utilized by the databases. Okay, but these two things will be utilized by the general applications. Okay, so if you deployed an application in the server, mainly it utilizes the CPU, it utilizes the memory. What is meant by the CPU? CPU is nothing but a number of cores. It indicates number of cores. Okay, how the cores will helpful for the application? If there are a n number of cores in our CPU, so that n number of threads will be run concurrently. So if your application is a concurrent based application, your application threads should be is equal to the number of the cores. Okay, that is the importance of an CPU. If the memory means we need an memory to run the application, right? So this memory is nothing but an RAM. Okay, this is the components of the server. Now we need to understand about horizontal scaling. Coming back to the horizontal scaling, you developed an application. Okay, you developed an application initially. It is consists of an user base of 10 users, and 10 users, it consumes 4 cores of CPU and 8 GB of RAM initially. Okay, it is having on server. At the initial stage of an application deployment. Okay, these 10 users. Okay, I already mentioned that the scalability means your application should be capable to support how many number of users will increase. Okay, even the number of users will increase, your application is capable to support. Then only the application is a scalable application. If there is a 10 users, if users was increases to 1 lakh, how many times it will increase? 10,000 times. Okay, 10,000 times increase. That means for 10 users, our system is capable of 4 cores of CPU with 8 GB of RAM. The 10,000 times will be the increase. How many cores of CPU it will be required? 40,000 cores. How many GB of the RAM it will be required? How many of the GB? 80,000 GB for maintaining the one server. Okay, which is the practically impossible. Which is practically, it's an impossible. So what we had to do, we will increase the number of servers. Number of servers to run our application smoothly. To run our application smoothly. For 10 users, one server capacity with 4 cores of CPU plus 8 GB of RAM. For 10,000, for 1 lakh users, how many servers it will be required? 10,000 servers. With 10,000 servers, 4 cores of CPU with 8 GB RAM. We will increase one server to the 1 lakh servers immediately when the load gets increases. This is called horizontal scaling. Okay, so your application should be a scalable. To maintain your application scalable, your application should be support of an horizontal scaling. Okay, let's understand the vertical scaling and also the dynamic scaling in a rough way. Okay, vertical scaling. Vertical scaling means if there is a one server with 4 cores of CPU with 8 GB RAM is increased to the capacity of 8 cores of CPU to 16 GB RAM. This is called vertical scaling. This is called vertical scaling. That means vertical scaling is nothing but making the one server strong. Okay, this is how the vertical scaling will works. Now we will understand about dynamic scaling. Dynamic scaling is a mix of horizontal scaling plus vertical scaling. It's a mixture of both horizontal scaling and also the vertical scaling. So if you make an only your application is capable for the vertical scaling, it is not a scalable application, because suddenly the number of users get increases, our server is going to be down. Okay, increasing the servers of n number of servers is easy than increasing of a CPU and the RAM for the server. Okay, increasing the CPU and the RAM is a more costly than compared to the increasing the multiple number of servers. So to make your system scalable, your system should be supported with an horizontal scaling. Okay, now you can understand, you need to understand why the stateless application are only capable to scalability, are only capable for the scalability. Okay, we need to understand that. For the stateless application are only capable for horizontal scaling. Okay, stateful applications does not support horizontal scaling. Okay, stateful applications does not support the horizontal scaling. Why? Okay, already we understand that the stateful applications are, there is a information dependency between the two requests, right? Whereas the stateless applications was every request is independent for it. Okay, for example, if an application of a server 4 CPU with 4 GB RAM, okay, your users are increases, okay, your user get increases, so automatically what you did is you did an horizontal scaling. You are did an horizontal scaling, you increased another 2 servers of same capacity, 4 CPU with 4 GB RAM. This is also 4 CPU, 4 GB RAM. Imagine your application is a stateful application. For example, you developed an e-commerce application, stateful. Okay, if you e-commerce application, stateful application. If you one request is goes to server 2, server 2, and its functionality is add items to the cart. Okay, add items to the cart. If your application is a stateful, it goes to the server 2, the request is goes to the server 2, it added items to the cart, and it stored the information in the server memory. Stores in the information in the server memory of the server 2. Now what happened if you go to the payment? If you go to the payment, another request got fired. It will be MySQL goes to the server 3. It is not guaranteed, right? It maybe goes to the server 3. Then what will happen? Add items to the cart is stored in the server memory of server 2. It is not present in the server 3. So there is a ambiguity will be erased for the users. Okay, suddenly your added cart is empty. It causes frustration to the users. Then automatically your application users are down. Okay, it is not perfect at all. So that's why Only the stateless applications are only capable for an horizontal scaling because the stateful applications information will be depends upon one server. If another request is goes to then another server, then automatically ambiguity will arises. Okay, so that's why the stateless applications with horizontal scaling applications are only the capable for the scalability. I hope you can understand why the stateless applications are only the capable for the scalability and why the horizontal scaling will be required for an application to make a scalable application. Okay. And third important factor is load balancing. Load balancing. Load balancing. Why the load balancers are required in the generally? The load balance are required in the name itself. It will be there to balance the load. Why it is required? Okay. For example, you had stateless application and application is also horizontally scalable. Okay, but there is no load balancer. What are the effects? Let's discuss about what are the effects. You had three servers. Okay, you had three servers. You are getting 1 lakh requests. All are stateless. Okay, each server is with 8 GB RAM, 8 core CPU capacity. All the three servers. If 1 lakh request is comes to your application, you are not guaranteed that requests are evenly distributed. Sometimes what will be happen? 40,000 requests will go to this server. 60,000 requests will goes to this server. There are 0 requests goes to this server. Then what will be happen? Then automatically these capacities are breached. There is a chances that any of the servers will might go down. Okay, might go down. This is an first effect. Another effect of the load balancer. You have a three servers again. If there is no load balancer, another effect. If you are having three servers, okay, this is a server one, server two, and server three. Okay, server one, server and server two. If one of the server is goes down, okay, without the load balancer, what will happen? Request might goes to the server two. Okay, if same scenario of 60,000 requests which goes to the servers two, and this one goes to the server one, this goes to the server three, automatically the 60,000 requests are failed. Okay, to solve these problems, we need the load balancer. Okay, load balancer does two things. It sends requests distributedly to all the servers, to all the healthy servers. That is a key point here. Okay, even one of the server is goes down, the request was evenly distributed to the healthy servers. That is an advantage of the load balancer. So that's why your application should supports the load balancing also to make a scalability. Okay. And next important factor is auto scaling. Auto scaling. Auto scaling is also the most important factor because today the applications all are distributed in the cloud. Mostly majority of applications will be deployed into the cloud. Okay. For example, if you take an example of an Amazon, so that you can easily understand. Okay, why the auto scaling is also an important factor. Amazon in normal days per hour 10 lakh requests are coming. Okay, whatever in the case, there is a big billion day or big billion sale per hour. How many requests? Unimaginable. Okay, auto scaling feature is it automatically increases the servers. It is automatically perform the horizontal scaling based upon the traffic coming to our application. That is a feature. Okay, auto scaling. It is generally for all the applications which we are deploying in the cloud. It had automatically had that feature. It is having that setting. For which applications which is deployed in the on-prem, they need to be keep their servers ready. Okay, they would manually route their traffic there automatically. Okay, next important factor is caching. Why the caching is also the most important to make your application scalable. We need to understand. Without the caching, what will happen? We need to understand the scenario first. We had the database of MySQL. Okay, there are two tables. This is table one. This is table two. Okay, it consists of 1 million rows. It consists of 2 million rows. Okay, we had one query. One query. Same query. Okay, one query. Perform join. Join between these tables. Okay, what happened? There are two things happening here. First one is time taken to perform join. Join is more. Second thing is memory or RAM of DB server is increased. Imagine if same query we need to perform for every 5 minutes. That is a requirement. That is a functional requirement. Just imagine if the same query we need to perform for every 5 minutes, then what will happen? These two things can happen recurrently. And RAM of an database server is also the increases recurrently. At the same time, the other request got also affected. To avoid this problem, we place a cache. This is a cache. This is a database. Cache is generally key value store. We will discuss in further videos in detailing about the caching. First, we need to understand why the caching is requirement, general requirement. Okay. If the same request first time, it will be goes to the cache. Generally, where there are many cache patterns, but one pattern I will explain for the better understanding. Okay. If the request was come to the cache, it doesn't have data for the very first time. Then it will be reached to database. Okay. Then what will happen? The perform the query first time, the time taken more, and it takes consumes the RAM, and the later it comes to the cache. Later it comes to the cache, and it places the cache. It places the value in the cache, and it returns the output. This is input. This is output. Okay. After 5 minutes, if you get another request, it doesn't go to the database. It will be look into the cache, and again it will be gets into the output. Okay. So that even the data is increases. If your request is performed multiple times, the RAM and the time taken of that request will be the saved by using the cache. Okay, these are the benefits of the cache. The cache is a key value stores, just like hash map, for the better understanding. Okay, getting the value from the hash map is order of one time complexity rise, right? So time taken is also the improved. At the same time, there is no consumption of the database server memory. It will be safe. Okay, so that the caching is also the most important factor to build a scalable system. Sixth one is database sharding. It is like an horizontal scaling concept only. Horizontal scaling is used for an application, but database sharding is used for our databases generally. Okay. If user had 1 lakh requests, 1 lakh users. Okay. Now I'm talking about number of users. Okay. Number of users are getting increases. These are all talking about some number of requests and number of users. Now the number of users concept I'm talking. Okay. There are the 1 lakh users. We are having a huge data. Okay. For a database, for one server, we need CPU, we need disk, at the same time we need RAM. Okay. This is server. Okay. If your database is built in one server, for MySQL, there is having a one server, there is a 1 lakh users. We need a consumption of more CPU, more disk, and more RAM. It is not possible. Okay. Then how you are maintaining the database in the case? For the database, you're having one server, and we are having hashing mechanism here. Okay. And we are having multiple servers in the backend. Okay. This server may be horizontal scaling we can used. Okay. If a request is comes to this server, what will be happen? Hashing mechanism performs. It will be it will be told that which server we need to give. Okay. That means if there is a 1 lakh users will be splits here. 30,000 users will goes to the this one. 30,000 users will be the goes to this one. 40,000 users will goes to this. Okay, in this way. For example, for this one, user 1 to user 30,000. User 30,000 to user 60,000. This one user 60,000 to user 1 lakh. Okay. If user 1 data is coming to this server, it performs an hashing. Hashing algorithm is always told that it maintains an equilibrium between these three servers. Okay, it shows that it will give say one as an output, then the request will be goes to all read request and all the write request always goes to the server. Okay, this is how it works. For example, if another user 1 lakh one user it will comes, the hashing algorithm would will work with always it gives an within the number of servers. The output will be range of number of servers. If the number of servers are 3, the output of an hashing algorithm is always between 1 to 3. That too, it is also output is depends upon the balancing between the three servers. It is also maintains a balancing, and output is also comes within the number of servers, so that the user data will be the goes to that particular server. This is called that database sharding. Okay. If the number of users got increases and increases for one server with database, we can't scale, right? So that's why we are doing the partitioning with the number of users to make your system scalable. Okay. Next important factor is database partitioning. Sorry, not database partitioning, database replication. Database replication. Okay, database replication. The generally database sharding is usually do for the MySQL servers. Database replication we usually maintain for a caching. I already said that the cache is also the most important, right? So to maintain that cache, we need the servers. Okay, to maintain that cache, we are using the database replication. how the database replication generally used. Okay, we have 3 servers, for example. Okay, this is nothing but an master slave architecture. Okay, it will be act as master. Roughly, I'm explaining this because we are discussing about the factors, right? Each factor is a different subject again. It is having so much depth. I will make an videos on that each and every topic with in depth. Okay, currently I'm explaining the outline of it, the factors which affects the scalability. Okay, this is a master, this is a slave. Okay, this is a master, these two are the slaves. What is a master, what is a slaves, how it behaves? If the request, if there is a write request, it comes to here. Always write request is goes to the master. Goes to the master. From the master, replication is going on. It goes to the slaves. Write request. If there is a read requests, read request all directly goes to the slaves. This is how it works. Generally, in the cache applications, the reads are more than writes, right? So to support the reads, we have the slaves. For write applications, always goes to the master. From the master, the replication will be goes on automatically. What happened if the master got down? If the master got down, next slave will become the master. Next slave will become the master. Okay, this is how the data replication framework will works. Okay, and third, the last, but also the most important thing is asynchronous processing. Okay, your application should support and asynchronously. Asynchronous processing should be required in some cases to maintain the scalability. Okay, what is asynchronous processing? Asynchronous processing is nothing but an two requests processing at the same time. Two requests processing at the same time. That is nothing but an asynchronous processing. Okay, synchronous processing means the server is capable to take then one request at the time. That is not works. Okay, the multiple requests, if the 1 lakh requests, if the number of requests is increases, if you processing the request by request, request to request, it doesn't works, right? It should be capable to process the asynchronous processing of the requests. This is the most important thing. Okay, so these are the 8 factors are most essentially required to make our systems scalable. Okay, scalability means our application should support, should not be down. Even the number of users are increases, number of requests will be the increases, number of data is also the increases. Okay, to deploy our application into the production, scalability is one of the most important factor. In this scalability as an important factor, these are the underlying 8 concepts plays an most important key role. Okay, I hope that you understand all these 8 concepts more clearly. Please like, share, and subscribe if you like this video. Thank you.